Okay, thank you once again for joining. I think we'll get started in earnest. Welcome to this webinar devoted to quality engineering and assurance in an age of artificial intelligence. My name is John Bernstein. I'll guide you through this conversation. It's a conversation where we want to explore the challenges, the opportunities organizations like yours are facing up to, and discover how best to operationalize trust and scale AI-led quality engineering. To do that, delighted to be joined by David Colwell from Tricentis and by Mike Turner from Cognizant. Great to have you both with us. Just a quick note to say that you can pose questions to both Mike and to David as we go through the next 30 minutes or so. Simply put your questions into the chat. We'll pick up as many questions as we can between now and the end of our time together. But let's get started. A few questions of my own. David, we'll start with you if that's okay. And it's a bit of a sort of scene setting question, if you like. I suppose 5 years ago, using AI for testing just simply wasn't on the table. Since then, we've seen experimentation, we've seen some tangible proofs of concept. I wonder how you would characterize it, David. Where are we today?
Yeah, so it's a fascinating question because where are we at? 2025? 5.5 years ago, I was speaking at a Tricentis conference in Vienna, and some of you may have been there actually from Cognizant. And we were presenting what we called the first iteration of artificial intelligence in Tricent in testing. It was something we shipped initially under the name Neo. We now call it Vision AI. And I think it provides a good ground to show how far we've come. Because at that time, we thought AI in testing was maybe a good thing for helping you automate a bit better, helping, stabilize the automation. It was very kind of narrowly focused on specific tasks with specific inputs and outputs. And it was very hard work to get one of those things done. You had to collect a data set and label it and build the use case and then build the program and ship it. Months to years of work to get a single use case out. What changed is AI learned to understand us. It learned to understand natural language. It learned to speak. Sometimes it learns to speak too much. Sometimes it learns to speak a lie, but it's learned to speak nonetheless. And because we express almost everything in testing in natural language, our requirements are natural language, even our test data is natural language. You don't ask for select star from account tables where blah, blah, blah. You say, no, this test requires an account that has more than $100 of balance. So we talk in business words, but the AI spoke numbers. Now the AI speaks business words. It feels a lot more like we've got an intern working for us that we can say, hey, I've got tasks that I want you to do. Take this requirement. Tell me, is there any lack of clarity in it? Build me some test cases. Then take those test cases, start making automation. And it's strange how close AI is just sort of mirroring a human, not evolution, but just a human's natural life cycle. Like
Very
it's
good.
born, yeah. Now
David,
it's
thank you
using
for that.
tools.
And I love this idea of speaking the same language. Maybe we'll get into some of the challenges as well as that description that you give. Mike, do you want to pick up this idea of how AI is changing quality engineering and assurance? What can we test today that perhaps we couldn't test yesterday?
Yeah, sure. And I think just to mirror what David was saying earlier around how far we've come since 2020, at Cognizant, almost 30% of the code that we write today is written by AI. So this has very rapidly become something that's extremely mainstream and common. And obviously testing, ultimately is software development now. We're really looking at using automation to carry out testing. So it's I would say particularly over the past couple of years has come from something which didn't really exist to something that's really very mainstream in the way we think about quality, the way that we test software products, but also now starting to go beyond software. I think again, as David was saying, because AI can understand natural language, what that's allowing us to do is to take software testing concepts and apply those to things that are not software. So we can look at voice conversations between people. We can look at text on a website. We can look at images. We can look at videos, and a lot of those things, we couldn't really test those things before, and now because AI can understand them, we can plug them into automation, and so the scope of what it's possible to automate in terms of quality assurance is exploding.
Very
And I
good.
think also the role of the quality engineer then is changing with that, where it's becoming, much closer to the engineering side of things than the quality side of things, because testing all of those new intricate parts of the system are, so much more involved and complex.
Just a quick aside, you said 30% of the code is now automated, done by AI. Is it the low-hanging fruit? Is it the easier stuff to do, or is it a bit more nuanced than that?
So typically the way that a developer will work with an AI tool is that there's a few different models where you can use it to tell it what you want and it will complete based on your instructions. But also now we're starting to see agent-based coding assistants, which will not have a user involved at all. So they might look at code when it's checked in to your source code repository, and in the background do a bunch of work on that in terms of checking it that it makes sense and it follows all of the standards and it's appropriate. So um, I would say it's not so much the low hanging fruit as it's a collaboration. It's kind of a peer-to-peer collaboration. A lot of times where you've got something particularly difficult to do, like you might need to restructure some code, let's say, that's quite complicated. AI is really helpful in that situation, but I think that help also comes with the added risk that obviously if you don't understand what the AI is doing, you're opening yourself up to lots of there are lots of new risks that come with AI generated code, where AI does things like it might hard code an answer to make sure that a test passes because it's the fastest way to do that, and so you really do need to pay attention to what's coming out of those tools.
Very good. And I guess that word risk, David, leads us on to another question. We talked quite enthusiastically about the change that's happened in the last 5 years, but what are the challenges that come with AI quality testing?
Yeah, so we follow a very similar practice in Tricentis with AI coding. Almost all of our engineers are using AI coding tools to write their code, almost to the point where we're not entirely sure if any of the code that's been checked in the last 6 months was entirely human written. But we've identified some syndromes of AI. To narrow them down a little bit, AI is a very good coder and a very stupid engineer. It's probably the best way of saying it. Because like that comment that Mike just made about AI deciding to throw the answer to the question into the code so that the test passes, that happens a lot. Like the AI will run the tests and say, why are these tests failing? I can't figure it out. Try once or twice. And then you can see it's thinking. And so it'll say something like, I'll just put this answer into the code for now and I'll come back to it later. And it never does, because then you go later on, the tests all pass and it goes, yep, cool, I'm done, completed your task, hand it back over. But that's not the underlying symptom. That's just the tool. The tool has limitations. You need to learn how to use it. The problem is that we as humans feel some form of shame about slowing down the process. We don't like to be the reason that the code is not checked in. And so we're in this weird situation where there's a bunch of code on our laptop and it's running and it's compiling and the tests are passing and 1,000 files have changed and you're about to hit that commit button, but you have no idea if this is what works or not because you've lost control. The AI has gone beyond you. And so when you combine these sort of two things where you don't really own it anymore and it can do chronically stupid things at the same time and kind of cover up after itself, you end up in a world where the only real guardrail that's left is good testing, because we're not going to be able to change human nature. Humans are going to want to, move fast and say, "Yep, I've checked it in. We're doing great here. Yeah, I'm fast. Look at all my code." That's not something we even want to change. So we need to implement good testing practices. I think that's probably the biggest cure to the underlying risk problem. And
Very
there
good.
are others, but that's the major one.
And let's explore those others as we go along, and maybe start to explore, as you started to do yourself, some of the ways that we can get round it. Before we move on to some detail, Mike, the same question to you. What has David covered it, or are there other challenges that face us when we think about AI testing?
Well, I think it might be good to think about the other side of this. So obviously there's risk in terms of software development going faster and having AI generating software. I think the other big shift that we're seeing is obviously now it's AI is not just used for coding. Our applications now are starting to have AI features in them, and those AI features again are really different in terms of how you test them and how you assure their quality. You know, if you look at something that's written, particularly with generative AI, the quality of that service is going to be subjective. So it's very hard to specify this is good enough for this particular feature. Its capabilities are going to be emergent, so it will be able to do things that were never in a requirement or a specification. And how do you account for testing that? And then its behavior is going to be variable. So from day to day, you're going to see, different types of responses to the same input. And so those things are all really, really difficult to deal with from a testing perspective, which is always built from a kind of foundational principle of saying there is an objective acceptance criteria to a specification point, and the system will always, once it passes the test, it will always pass the test in any future iteration. So that shift as well, I think, is something that's really changing testing practices as we're expecting every single application within the next kind of 3 to 5 years is going to have significant AI functionality inside of it. And so this is, something that we also need to accommodate into how we work as quality professionals.
Very good. And we'll talk about that accommodating in a second, but it's really interesting because what I'm picking up is some of the things that are inherent in the characteristics of generative AI for sure are the things that might present a challenge. Certainly that idea of getting a different set of words each time that you ask for them, and how do you get around that? We'll come to that question in a second. I just wanted to remind everyone that's watching an opportunity to ask questions. Put your question in the chat. We'll get to those questions as and when. So, David, we talked about some of those issues. Just from a reviewing results point of view, what's different now compared to then? So if we introduce AI into the equation, what's different when it comes to reviewing results?
I think something that's different is like we built a muscle for peer review in the engineering community and in the testing community. We understand how to review the work of another person. And we built in there a bunch of assumptions about the way that people do their work. So we don't necessarily go line by line in a peer review and say, I need to know every single thing that this line does. You're looking for patterns. You're making some assumption that the person that you're working with is adhering to the practices and principles of your organization, and you're just trying to look for the gaps and to help guide and improve. With AI, all of those assumptions are incorrect. You don't know if it's adhering to the patterns of your organization. You can build rules and say, follow these rules, and you've got a better than average chance that it will. And so when you are in that world where you've got a high volume of change and you've got an untrusted partner that you're working with committing this change, the way you do peer review needs to change. And some people are throwing AI at this to be the answer to the other problem, is saying, hey, let's get AI to review AI. It's not a bad solution. It does catch defects for reasons that are too boringly mathematical to go into here. But that process, the skill that we need to develop as humans is to start being more skeptical of what we get back, to start looking a little more closely and saying, like we had a great example, would have been about a month and a half ago, where we had an AI write code that was interacting between two system applications. It was all API work. And it wrote a bunch of checks in there where it expected all the failures to have a cross emoji in them, because that's how it understands failure, is someone puts a tick if it works and a cross if it doesn't. So our code review picked up, well, human code review said, what on earth are you writing? There's no way that the API is going to respond with a cross emoji to this. And so there was just a case of that type of change, that type of check that would not be normally picked up by testing, would not normally be picked up by a code review unless you're being much, much more skeptical of what you get.
So there's a mixture here, David. There's some things that the unintended consequences, and you end up doing the AI ends up doing it wrong, and there are occasions where the AI just does it differently. And when it does it differently, is it a question of us just needing to get used to that and to adapt to that, or do we need to continue to educate the AI?
That is a question. It's almost a philosophical argument amongst
Mhm.
engineers. Like when I know the original one was like spaces versus tabs, but there's also like within the testing world in automation for the longest time. Do we do page object models? Do we do keywords? Like these policies of how you do your work are not settled amongst humanity. But what we've found in AI is the more you stick to the way the AI does it, if it's not harmful, you get better results because it's a giant averaging machine. So it's trying to do something the most normal way that it can think of. And if you can fit within that, then you get much better results, you get them faster, you get more first time accuracy, which has led to strange practices, like people saying, hey, we're going to write this enterprise app in Python because AI understands Python really well. And so it can write this app really well in Python. If we wrote it in Rust, for example, then it would struggle. It wouldn't know the libraries as well. So it's starting to have an impact on decisions that we make. And is that a good or bad thing is kind of a decision for you. Like, can you tolerate Python? If not, like, sure, make it write Rust, but you have to live with the cost. And then training is an option for you. It's an expensive option, but it is an option.
Mike, I'd like to
Yeah, I
pick
think
up on that point that you made a little bit earlier, this idea that the generative AI produces different words each time. So I just wonder how you validate and benchmark when the AI response tomorrow won't be exactly the same as the AI response that you're seeing today.
yeah, something there's a big issue, and if you look out in, I guess, in the on the internet, in social media, there's a lot of commentary on, you know, this model is having a bad week this week and it's been downgraded and it's producing, even to the extent where, um, you know, a system could successfully process a task last week, but this week it can't handle exactly the same thing in exactly the same circumstances. So really, we move from a world where we're testing systems on release to one where we're evaluating them continuously. We need to be looking at these systems are going to be variable, the outputs are going to be different, so we need measures of quality that have tolerance around them. It's not like there's a right answer and then a wrong answer. And a big part of what we need to do to assure AI systems is then to have quite a broad range of different metrics and measurements that saying, this is it's the results are accurate, the user feedback is good, it's not leaking any IP. It's not saying anything toxic. It's not contradicting what it's supposed to do as its purpose as a system. There are a lot of different, quite nuanced measurements that we need to continually measure, in usage pretty much every time somebody accesses that system. So it becomes more of a challenge of what we would call observability than testing. And I think having those AI features is really starting to blur that line between, it's not something where I guess you do like really deep testing on release to be confident, but that still doesn't mean that, once the system is deployed, it's going to work effectively.
Very good.
Can
Yeah,
I add a
please,
Can I
David.
just a bit of color there? Something we've been shipping AI systems to real customers for some time now. We've noticed a marked change in behavior and how people interact with these systems. That change in behavior is people don't analyze an AI system when they pick it up the first time and they start to use it. They do something closer to interviewing it.
Mm.
They ask it a few questions and they very quickly judge the quality based on the type of responses they get. And the number of questions that you give it is 3 on average. There's some people are more patient, some people are less patient. But if the responses you get back are quote unquote stupid after 3 tries, then people generally just sort of go, well, this is a stupid model. This is a stupid system. It doesn't. It's like you started to interview someone and they got the first 3 questions wrong. You're like, okay, call the interview there. I'm not interested in going any further. So we started to realize there was a really high need for first past post quality. Like the thing you ship has to be good when you ship it. It has to give that really good first impression, and that our testers had no idea how to do that because they looked at things like, hey, it gave a wrong answer. That's a defect. I'll put that defect in Jira, and now we'll wait for that to be resolved. And the machine learning teams are like, that's not a defect. That's a data point. If it gave 100 right and 1 wrong, then that's an excellent result. So why are you raising this defect? So I think it's critical to realize that both are true at the same time. You
Yeah.
have to monitor these things in production. You absolutely must. If you don't, you have no idea what's happening and they go off the rails quickly. And you have to test them before you put them in production. Otherwise, you very quickly burn the goodwill of your customer base.
We'll come to some questions from the audience in a second. I just wanted to put one more point to both you. David, I'll start with you around hallucinations. So another sort of characteristic that people are familiar with when it comes to generative AI. So how do you detect hallucinations? How do you remove hallucinations?
Sure. So there's been various attempts at this over time. I think the most promising one at the moment is training hallucination prevention into the model, because there was a recent paper, actually, it's only, I think, 4 days old, from OpenAI on how they're doing this, where instead of giving the model a yes, you got it right or no, you got it wrong answer, which actually encourages the model to guess when it doesn't know, because it goes, oh, well, if I get rewarded when I get it right, and I can't give no response because that wasn't an option. So I'm going to make a guess and maybe I'll get something right and I'll get part of a reward. That'd be great. But OpenAI recently said, well, what if we did more like standardized testing and said, well, actually, no, if you get it wrong, you get penalized, like you get a big negative. But if you don't answer when you don't know, then you get part of a reward. So they're kind of encouraging uncertainty in the model. That's more like that's a better attempt at a cure for
And that
hallucinations.
uncertainty that it's introducing is helpful from your point of view?
It's necessary because hallucinations are a feature of generative AI, not a bug. If you wanted precise answers to exacting questions, you should be using a database. Generative AI, you're asking it to do a task for you that isn't copy from here to here, get it from Stack Overflow. You're saying, here's my requirement, write me code. And the code should be the thing that's in my head that I'm ineffectively communicating to you through the keyboard. So you kind of want it to hallucinate a bit of that stuff. You don't want it to come back to you with every single question. But when it does something that isn't in that gap between what we thought in our head and what was communicated on the keyboard, we go, okay, that's a bad hallucination.
Mike,
So
your
yeah.
your thoughts on, forgive me for cutting across, your thoughts on hallucinations. I posed the question is how do we remove them? Maybe we just can't because they are a feature, not a bug.
So there's a couple of things that we're doing kind of in this space to help, I guess, practically today with the models we have. That the first one is really around what we would call context engineering. So as David said, LLMs are very bad information retrieval systems. They're not search engines. They're not designed to go into their training and regurgitate what they were trained on. And so a lot of the times when you get hallucination is because they're being asked an information retrieval question and they just make something up because they don't have the ability to do that. So if you can add that information either into the input or into tools that the LLM can access, then it becomes a much simpler question for the LLM to answer. So if if you're saying there's 4 restaurants and tell me which, these are the details of the restaurants, tell me which is the best one, is a much simpler question than just which is the best restaurant in this place at this time, where it will have no chance to answer. So adding context into the environment massively reduces hallucinations. And we can even bring that down to the level where we can force the LLM to only reply with authoritative content. So we do a lot of work in regulated environments, in safety critical environments, things like life sciences, R&D, where we do exactly this kind of thing, where the LLM will actually just output a search query, which will run on a search engine and then provide the actual clinical research document that matches the user's question. So there's no chance of any hallucination happening in that context. I think the other interesting thing we're doing a lot of research in at the moment is a concept that we call semantic density, which is you can actually, as an LLM is performing an operation, you can open the hood on the LLM and have a look at the neural network inside of the LLM, and you can trace the processing path of how your question gets processed. By looking at that internal kind of processing chain of the neural network, what you can see is it kind of going through like the middle of the neural network and doing something that's very mainstream that's happened a lot of times, or is it going out to the edges and doing something a bit weird? And it turns out that we call this semantic density as a concept, but you can actually turn that into a confidence score. So you can actually ask the LLM a question, and the LLM will think it's 100% confident, like David was saying. It's trained to be very confident in its answer, but when you look at the internals of the LLM, you know it's winging it, and you can see that actually the confidence level is less. So we're looking at a lot of these kind of techniques as well, of like, how can I supplement what the LLM is saying with other metadata about the environment, which actually says, well, it thinks this is the right answer, but it actually hasn't got a clue. So those are a couple of practical things that we're doing at the moment.
All right, thanks very much. Let's take a question. There was an appeal for questions. I got a couple of questions before we started from elsewhere, and I'll put those to you. Quick answers if you wouldn't mind, because we are rapidly running out of time. So, Mike, I'll stick with you with the first question. Isn't this just a fad? And the this in this context of this question is AI. Isn't this just a fad? Why should we invest in AI tools, Mike?
Well, I think we probably past the point, certainly in terms of our business, where we're convinced that this is it's absolutely progressing, and the rate of progress is exponential. There's some really interesting data points. I think there's an organization called metr.org who they track the amount of time, the maximum duration that an AI the maximum duration of a task that an AI can complete with 50% accuracy. So that's the measure that they track. And what they've seen is over the past 7 years, that duration has doubled consistently every 6 months. So every 6 months, AI can do like double the length of tasks or more complex tasks. And we're seeing that, very trending over many years consistently. I think if we look at the practical situations in terms of certainly from an engineering perspective, the use of AI is having very material impacts on our productivity, the quality of software we can create, and it's very mainstream in what we can do. I think the piece that we haven't maybe seen fully materialize yet is then that kind of consumer experience space, and I think that's where maybe a lot of the doubts come in, is because we see, obviously ChatGPT is very successful, and Anthropic and so on. Those consumer AI services are having huge impacts, but we haven't seen, like we saw in the dot-com era, we haven't seen like every big corporation moving their customer experience across to AI.
Mike,
Cultural change happen.
very good. Thank you for that. I wanted to quickly pose the same question to you, David. I'm guessing you don't think it's a fad.
No, it's something in the title of my job, I think. So no, AI is not a fad. It is solving. It's another wave of automation, and like every wave of automation that came before it, we're starting with the easiest things first, and we get a very high productivity per effort input. The change with this wave of automation is it's automation of thinking. That's realistically what we've been working to automate. And we don't know what the upper limit on that is because we tend to do a lot of it and we don't register all our thinking with the SEC, so to speak. So this is far from a fad. I think that the capabilities that AI continues to pop up in these new models and new capabilities when new context engineering techniques, agentic usage techniques, as these more and more of these emerge, more and more of the scope of work that we do is becoming agentified. And so I think that it's here to stay, and the way that we work needs to begin adapting rapidly to deal with that. We
Very
need new
good.
skills and new ways of working.
Which leads me to another question that was sent in, and David, I'll get your view on this first. What does it mean for jobs? What will the future role of the software engineer look like? Will there be one?
So I'm somewhat optimistic on this because I've seen the productivity of AI for software engineering in the hands of non-software engineers result in hilariously bad outcomes. And so I see the productivity of AI in the hands of a good software engineer multiplying a good software engineer. And in those spaces, I don't think the scope of work, the scope of human innovation is limited. We have a huge potential to solve more and more problems more and more quickly. So I think that this is going to, there will be an initial impact on jobs as organizations say, hey, we had this much work to do and now we need less people to do it. But then as competitive forces come back in and say, hey, all of our competitors are now moving faster as well. Like everyone's got more innovation, everyone's moving quicker. Those people will be brought back in to guide the AI. So as a force multiplier, we are the denominator that it's multiplying.
Very good. Mike, same question. Do you share David's optimism?
Yeah, I think so broadly. What we see is that there are effectively three things simultaneously happening to demand for technology labor. So the first thing is simple tasks are getting automated. So there is a little bit of a contraction in terms of more junior resources. There is automation and labor replacement happening at the base of the pyramid, if you like. But simultaneously, in more senior roles, there's this thing of the ability of AI actually is able to extend people's cognitive abilities beyond the limits of what a human could do on their own. So you effectively in the senior end of the pyramid, you've got now superpowers, you've got super engineers who can do things that weren't even humanly possible before, and that's kind of increasing impact, increasing value, increasing demand. And then really the third effect is one of career acceleration. So if you think about an engineer at any stage in their career having really great support around them, these kind of AI peer programmers or guidance on how to learn new technologies, how to do things quickly, so they can spread their skills broader, they can get better experience, they can be more safe, more controlled in what they do. And so that's offsetting a little bit as the base of the pyramid contracts slightly, that's offset by the fact that people can progress in their careers and they can do some of the more senior roles more earlier, more effectively. So yeah, I think net, as David said, there's no company on earth that has nothing to do with technology. If they all had more technology capacity, there's a ton of opportunities to go after. And really this is quite a big shift in how people work, but at the end of the day, I've never seen AI yet be able to actually kind of automate what an engineer does. It can automate tasks, but it can't take away wisdom, discernment, taste, judgment. It can't take away accountability. It can't deal with the kind of very long memory, very long lifetimes of 10 years ago something happened and that's important and I need to know that for today. So
Very good, Mike. Thank you
these
for
are the
that.
current levels. Yeah.
We're heading rapidly towards the end of our time together. I want to just fit one more question in to you both. I'm going to ask you to answer it briskly. Again, Mike, I'll start with you and I'll come to you, David, in a second. The final question is a piece of advice, really. What is the one piece of advice you would give to viewers embarking on their AI quality assurance journey? Give me sort of 30 seconds or so, if you wouldn't mind.
Then I'll talk fast and cheat. I'm going to give two. So the first piece of advice is go make gratuitous use of AI tooling. Using it is the only way to understand it better, and it gives you that baseline skill. The second is make sure that your domain skills you brush up and you keep firm on things like peer review and understanding the real expert part of your job, because that's the durable asset in a world of AI.
Very good. David, you were brief, so I'll let you off the cheating aspect of that answer. One thought, one piece of advice, please, Mike.
So for me, I would say this really comes back to like a human-centered approach. I mean, we're talking a lot about technology, we're talking a lot about AI, but at the end of the day, for any system in any context, it's really coming back to who is the human that it's there to serve, what do they need, what do they expect, what's their use case, and that will change drastically people's tolerance for accuracy and you know, how a system might be structured, and ultimately, I mean, we touched on this a little bit earlier, that kind of adoption cliff where you interview the system and then you fail, and then you don't go back and use it again. All really comes down to this human perspective. So you know, one as David was saying, you know, 99 right and one wrong. In some situations, that's a fantastic result. In some situations, that's a terrible result. It all comes back down to the human at the center of the whole system. So, you know, that I think is something to really sort of start from that perspective. And
Excellent. Mike, forgive me, we are running out of time, as you might tell. Mike, David, thank you so much for your expertise and your contributions today. And thank you all very much for watching. We will make this webinar available to watch on demand. So if you want to view it again, there's parts of it you want to see again, or to share it indeed with colleagues, we'll make the link available in due course. On behalf of Cognizant, on behalf of Tricentis, thanks again for being with us today. We'll see you next time.